We come to Newton's laws now, and as I have stated, just about everyone is familiar with Newton's laws of motion. The first law is known as law of inertia. The second law is known as force equal to ma, that is mass into acceleration. And the third law is that action and reaction are equal and are in opposite direction. So we have been studying that since school times, but here we apply them to fluids also and see the implications, see the forces and the related effects that they have on fluid movements and the effects of the forces. So the relation between motions of the bodies and the forces acting on them. Newton's first law: a body at rest remains at rest, or if it is in motion, it remains in motion unless there is no external force applied on it, or if the net resultant force is zero. So the same thing. So this is known as law of inertia. That is, it tries to retain its whatever condition the body is in. If it is moving, it tries to keep moving. It has a tendency to keep moving. And if it is still, it has a tendency to stay still and not move. Newton's second law, the acceleration, this is a very widely used law also, and it is used very widely in mathematics, physics, engineering, and so on. The acceleration of a body is proportional to the net force acting on it and is inversely proportional to its mass. So it's obvious from here F is equal to ma, and m is for mass of the body that we are considering if it is a certain fluid, and a is its acceleration. F is the net force that is acting on it, and it's a vector quantity since acceleration is a vector quantity. And likewise it has said that the acceleration is inversely proportional to mass. That is, if I keep a on one side, it will become F over m, and that means a is inversely proportional to 1 over m. So small algebra that everybody is familiar with. And Newton's third law is, when a body exerts a force on the second body, the second body exerts an equal and opposite force on the first body in the opposite direction, as we have stated. Therefore, the direction of an exposed reaction force depends on the body taken as the system as a whole. If we need to write it in mathematical terms, as I have just written and mentioned, that F is a force and it's a vector quantity. So vector quantity has a direction, and therefore you see an arrow there. And similarly, acceleration is also a vector quantity, and so is velocity, and therefore they appear with a line on top of them. And even if it is not there, then we in mathematics, we are familiar that these are vector quantities and they have a direction. So force is equal to mass into acceleration. What is acceleration? Acceleration is rate of change of velocity with respect to time. So that is mathematically represented as d by dt of the quantity v. D by dt, rate of change of v with respect to t, is written here, and this can also be written as d by dt into m into v, because this can be clubbed together, mass and velocity can be clubbed together, because mass is a scalar quantity and it cannot be created or destroyed, and therefore dm by dt will be zero anyway. So even if we write it this way or this way, both of them are okay. But these three are very familiar forms that the second law of motion, Newton's law of motion, is represented in mathematical terms. You are already familiar with momentum also, but we formally define here momentum as the product of mass into velocity, and mass into velocity of the body is known as momentum, which is a very important term, although very simple, but we shall be using them again and again because it plays in action of forces time and again. Newton's second law is usually referred to as linear momentum equation.